Now, here are some important conclusions derived from the above series. Number 1. Less is the value of E naught Mn plus oblique M. Or in other words, less is the value of SRP. M is the stronger reducing agent. That's why lithium is the strongest reducing agent in aqueous medium. Second point is, more is the value of SRP. That is, more is the value of E naught Mn plus oblique M. Then M is a stronger oxidizing agent. Therefore, F2 is the strongest oxidizing agent in aqueous medium. The third conclusion is that a metal occupying higher position can displace the other occupying lower position from its salt solution. For example, the reaction Cu plus 2 silver nitrate aqueous gives us copper nitrate aqueous plus 2 silver solid. This reaction is possible, but the reverse is not. I mean to say, if you put a copper rod in aqueous silver nitrate solution, then silver will be deposited on the copper. But if you put a silver rod in the aqueous solution of copper nitrate, nothing would happen. It is because copper can replace silver. Why? Because copper occupies a higher place than silver in the electrochemical series. Similarly, consider the following reaction. It is 2 times AgCN whole 2 minus a complex sign plus zinc, that gives us another complex ZnCN whole 4 with 2 negative charge plus 2 Ag. Now this reaction is also possible as given in this equation, but the reverse is not possible because zinc occupies a place above silver. Hence zinc can replace silver, silver cannot replace zinc. As you shall learn later on, this is an important equation used for the extraction of silver in the metallurgy of silver. Well, the fourth conclusion is E naught will remain the same whether a half cell reaction is multiplied or divided by any factor. Of course, delta G naught, which is known as the standard free energy change of the reaction, which is equal to minus times and E naught F, will undergo a change. I mean to say, whether we write 2 H ions plus 2 electron equal to H2, or we write H ion plus electron equal to 1 by 2 H2, the SRP value will remain the same. We have one more conclusion, number 5, that is, while forming an electrochemical cell, select anode whose SRP is less and cathode of higher SRP, so that E naught cell, which is equal to SRP of cathode minus SRP of anode, may become positive, and delta G naught, that is standard free energy change for the cell reaction, may become negative. Remember, for the spontaneous occurrence of a process, delta G must be negative, and under standard conditions, delta G naught must be negative. Therefore, for the cell, for example, zinc, zinc ions 1.0 m, salt bridge, copper ions 1.0 m, copper solid at 298 Kelvin. We are given from the electrochemical series that E naught Zn2 plus oblique zinc is equal to minus 0.76 volt and E naught Cu2 plus oblique Cu is equal to plus 0.34 volt. Hence, E naught cell will be equal to plus 0.34 minus 0.76 and that amounts to 1.1 volt. Thus, for any cell, if we get E cell in negative value, it means the cell reaction is not spontaneous under the given conditions. Hence, its polarities must be reversed to get a cell which may give current.